What up, guys? It's Jordan coming at you live from the engineering lab. Today I'm going to be doing example 30.3 out of the textbook. This is a basic Biot-Savart law problem. I have no idea if I'm saying that right. But what we have here is a ring. I can't do 3D drawing. So we have a ring here that has a current running through it in this direction, current I. We'll label radius R. Actually, we'll label radius A. I'll tell you why in a little bit. And then our infinitesimal resultant ds. And then let's look at a side view of it here. So I know this is aligned basically, but this is the circle if we tilted it that way. And we want to look at this point P. We're wanting to see how big the charge is at this point P that this ring is putting off, this loop of wire. So we'll make a little triangle here. We'll label this unit vector R. This angle is theta. That's point P. And then if we take a look at where our current's going, this way, current's going this way, it's bending down this way. We see our resultant force coming up this way. It's kind of awkward, but it's coming up this way, just like this. So this is our dB for the electric field. Then we can split this up into dBx and dB. Well, why did I do that? dBx, and this is dBy. Actually, we don't need dBy. This is dBx. This is our dB perpendicular force to P right here. This is also labeled as length x, and this point is point O. So what we're going to do is start with the basic. I'm actually going to move this down right here. Hopefully we can still see everything okay. What we're going to do is start with our basic Biot-Savart law equation, which is, this marker's kind of running out. See if this works. There we go. Which is dB is equal to permeability, a free space constant, times the current over 4 pi. And then this is our two different what's the word I'm looking for? Currents that are resulting into dB right here over r squared. There's a better word for that somewhere. And then what we can do, taking a look at this triangle, we have x here, a here, and r here. So r squared, let me copy this down first. R squared will become, man, I'm popular tonight, a squared plus x squared. And because r is just a unitary vector here, we can just simplify this to ds. But what we're wanting to do is look at dxb here. So just through trigonometry. Fubini, that's theta. So this right here would be cosine of theta, this dxb. So we can go ahead and tag on a cosine theta right here to make this dbx. Awesome. So then what we want to do to find bx here is take the differential of this equation. So let me move over here. Bx is equal to the differential of the constant times the current over 4 pi ds cosine theta over a squared plus x squared. So we can go ahead and take all these constants on the outside, so it becomes this ds cosine theta over a squared plus x squared. So after you take all these constants on the outside, we'll want to simplify what cosine theta actually is. Let me grab a different colored marker here. Cosine theta, ooh, this one's good. Cosine theta, this is theta right here, is going to be equal to a over r here. But let's think about r in terms of a and x, which is going to be root a squared plus x squared through Pythagorean theorem. So we'll go ahead and simplify a over root a squared plus x squared into this equation. So we have 4 pi ds cosine theta, or sorry, not cosine theta anymore. This should be equal to a over, and if we think of this as being to the 1, and we take this out, this being to the 1/2, we can add these together and make it over a squared plus x squared to the 3/2. Yeah. So now what we can do is go ahead and integrate this in regards to ds, or sorry, in regards to a, from 0 to 2 pi. No, in regards from ds from 0 to 2 pi. So all that really ends up happening here is all that ends up happening here is us adding a 2 pi onto this equation, because if we added a 0, it would make everything 0. So because all this is doing is adding this s constant, that becomes 2 pi. So this really just becomes the constant I 4 pi times 2 pi a, sorry if you can't see, a squared plus x squared to the 3/2. And let's do some simplification here. This cancels out, this cancels out, so that becomes a 2. So our answer for b of x is equal to mu 0 I a over 2 a squared plus x squared to the 3/2. Let me double check. This is supposed to be a squared, because we're differentiating the circumference, which is 2 pi a. So there should be an extra a here, making this a squared. There you have it. That is our answer.